Basic chemical fabrication process. Single crystal growth, ingot. To making an ingot, a pure silicon seed crystal is placed into a molten sand bath. The crystal will be pulled out slowly as it is rotated. 1 mm per hour. The result is a pure silicon cylinder that is called an ingot. Example of completed ingot. This is a single crystal silicon ingot with length 110 cm. Preparing the wafers. The ingot is ground into the correct diameter for the wafers. Then, it is sliced into very thin wafers. This is usually done with a diamond saw. Wafer polishing. The wafers are polished in a series of combination chemical and mechanical polish processes. Lithography. Lithography is a process used to transfer patterns to each layer of the IC. Lithography sequence steps. The first is designer. Drawing the layer patterns on a layout editor. Next, silicon foundry. Masks generation from the layer patterns in the design database. The function of printing is to transfer the mask pattern to the wafer surface. Process the wafer to physically pattern each layer of the IC. Fiercely, photoresist application. The surface to be patterned is spin-coated with a light-sensitive organic polymer called photoresist. Next, printing, exposure. The mask pattern is developed on the photoresist, with UV light exposure. Depending on the type of photoresist, negative or positive, the exposed or unexposed parts of solvents. Development. The soluble photoresist is chemically removed. The developed photoresist acts as a mask for patterning of underlying layers and then is removed. Oxide growth, or oxide deposition. Oxide can be grown from silicon through heating in an oxidizing atmosphere. Gate oxide, device isolation. Oxidation consumes silicon. Silicon dioxide is deposited on materials other than silicon through reaction between gaseous silicon compounds and oxidizers. Insulation between different layers of metallization. Etching. Once the desired shape is patterned with photoresist, the etching process allows unprotected materials to be removed. Wet etching. This one uses chemicals. Dry or plasma etching. This one uses ionized gases. Diffusion and ion implementation. Doping materials are added to change the electrical characteristics of silicon locally through diffusion. Dopants deposited on silicon move through the lattice by thermal diffusion, high-temperature process. So, this one uses a Wells formation, where it can be N-well, or P-well. Ion implementation. Highly energized donor or acceptor atoms impinge on the surface and travel below it. Ion implementation use this too. The patterned silicon dioxide serves as an implementation mask. And, source and drain regions. Silicon deposition and metallization. Films of silicon can be added on the surface of a wafer. Epitaxy. Growth of a single crystal semiconductor film on a crystalline substrate. Polysilicon. Polycrystalline film with a granular structure obtained through deposition of silicon on an amorphous material. MOSFET gates. Metallization, deposition of metal layers by evaporation. Interconnections.
Created using PowToon.